In this problem today, we are going to go over example 3 from 4.2. The content objective, once again, is, students will be solving a system of equations through substitution method using these Desmos activity notes. So yesterday we talked about a system of equations and we want to look for the isolated variable. In this case, in equation number 1, the y is isolated. That means it's by itself. If we drew the sides in a box, then the y is in its own box. So that means we can look into the second equation and we can substitute in wherever we see a y value, the box that equals y. So in this case, that box is 6x plus 1. So nothing else happens to the other items or the other terms. We are just now replacing that y with the 3x minus 1. Remember, at this step, you want to make sure that you are dealing with the same variable. So we have all x's, so we can treat it like we're solving an equation. So to get rid of the parentheses, we need to distribute. Now notice this step right here. When we combine like terms, 6x minus 6x equals 0x, but please don't write that. That may be a little too confusing for you. Now, when the variables go away, there is nothing more that you can do. There's no more undo steps. There's no more inverse operations because the variable is gone. So this ends up being a true statement because the number on the left is identical to the number on the right. Now, true is not the answer. It leads you to the answer. Since it's a true statement, the answer is infinitely many solutions. So infinitely many solutions, if you remember graphing, it would be identical. The lines are the same. If we solved the second equation in slope-intercept form, you would get y equals 3x plus 1. So since it's a true statement, the answer is infinitely many solutions. Now, we have dealt with one solution in example 1, infinitely many solutions for 3a. And now let's go to the next slide and see what happens here. So this time, the second equation has an isolated variable. It's y. So I get to plug in that y value into the first equation. So then that whole thing, that 5x minus 4, goes inside the parentheses. Now you want to be careful here. This is a negative sign, but it really means negative 1. So then we can distribute 5x, and the negative 1 times 5x is negative 5x. Positive 4, because a negative and a negative is positive, and then it equals negative 4. Now notice at this step, 5x minus 5x, once again, goes away. Please don't write 0x or 0. Just write what's left over. Now, you have to be very careful. It looks like they're the same number, but they're not. One's a positive 4, one's a negative 4. Since they're not identical, this is a false statement. So a false statement the answer will be no solution. Now think if we were to graph these two lines, what a no solution would look like. It would look like two parallel lines. So these equations will end up having the same slope, but different y-intercept. But when we are using the substitution method like we are right now, we can tell right away if it's no solution, if the x's cancel out, and more importantly, if it's a false statement. So these are the two exceptions. So we're going to have one solution, which we learned in example 1, and then we have no solution or infinitely many that we just did in example 3. Now I'm going to record the try-its as well, and the exit ticket that was associated with this you will be doing on your own or during learning lab time. So here in the try-it example 3, it looks like the x and y are isolated in example 1 or equation number 1, but you have to be careful. If we were to actually box up x plus y equals -4, they're together, so that would not be isolated. However, if you look at the second equation, our y is isolated. So since our y is isolated, that means this whole box can be substituted into the y. Notice it's a +1 for the coefficient, so I am not going to write any parentheses because there's no coefficient in front. So if you want to do parentheses, you can, just like this. It's up to you. But since there's no parentheses, they're not really needed. I'm sorry, there's no coefficient. It's a +1, so it would get you the same. So x plus a -x goes away. Then we're left with 5 equals -4, which is a false statement. 5 can never equal -4. So once again, it's a no solution. I'm trying to type too fast, so it's a no solution because the work became a false statement. Or you can say it's a false statement, so the answer is no solution. So it's really up to you how you want to word it, but you do have to justify. All right, try it example number 3. In this, the y is isolated, so I can circle the -2x and I can put it into this y. So then I have 2x. Once again, there's no coefficient other than 1 in front of y, so I don't need to use parentheses. So 2x, take away 2x goes away. We're left with 5 equals 5, which is a true statement. So it's a true statement. So the answer is infinitely many solutions. So these are the notes on example 3. Yesterday we did the notes on example 1. So I will keep the video separate and then I will add one that is together for both example 1 and 3.